I just paid $200 for a 10 Gbps dedicated server, ran a speed test and got 2 Gbps. I called the support screaming at them and they calmly said it's working as intended and hung up the call on me. Turns out I was the idiot. Not because the server was slow, because I had no idea that how actually to test it. Here is the truth. More than 95% who are paying for 10 Gbps server have zero clue if they are actually getting what they have paid for. They ran speedtest.net once, they see a random number, they either celebrate or get frustrated. That is not testing, it's gambling. You are paying the enterprise's money for the hardware which you can't even verify. So today I will be showing you the exact process to test your 10 Gbps server properly. System specs, disk speed, real network throughput with IPERF3 and CPU benchmark. By the end you will know provider is legit or you should be getting your money back. So here are the 4-step processes which we'll follow to conduct this test. Install PuTTY in your OS. Put your IP address on that section and log in by writing the root and the password. Then run the script which is mentioned below. So in this test, we will be looking into 4 parameters. System overview. Before running any benchmark, you need to verify your actual hardware. So this server which we are testing is an Intel Xeon Gold 5118 with 48 cores running at 2.3 GHz, 125.5 GB of RAM and 1.7 TB of storage. Running Ubuntu 24.04 LTS with kernel 6.680. Here is what most people miss. Check if AES-NI and VMX is enabled. Here AES-NI means hardware accelerated encryption. It's crucial for VPNs and secure workloads. VMX means virtualization support. If you're running VMs or containers, you need this. After checking these parameters, you will run the test. So here the VM shows none. That means it's not a virtual machine. This is a bare metal machine, not a virtual instance. This matters because virtualized servers often have throttled I/O and network performance. So if you're paying for 10 Gbps on a VM, you're probably not getting it. So the server which we're using is located on Amsterdam on RedSwitches network, AS50049. The locations matters because it affects the latency and peering quality to major internet exchanges. Always verify these basics first. If your provider can't show you your real hardware spec, that's a red flag. Second, disk speed. Disk performance determines that how fast your application can read and write data. So here we are using Fleo to test different block sizes because real workload don't just use one pattern. So here are the results at 4K block size. So this is what database typically uses. Here we are getting 96 Mbps read and 96 Mbps write. That's a solid random I/O. At 64K blocks, 714 Mbps read and 714 Mbps write. That 143 Gbps total throughput. For 512K blocks, 663 Mbps read and 698 Mbps write, totaling to 1.36 Gbps. And at 1 MB blocks, 586 Mbps read to 626 Mbps write, 0.21 Gbps of total throughput. So what does it tell us? That this NVMe capable of over 1 Gbps sequential throughput, perfect for video streaming, large file transfer or database workloads. Here is the keys inside here. Always test it with mixed read-write patterns. Ideally here 50-50. Third part, the network test. So this is the most important test for the 10 Gbps server. We are here using the IPERF3 because it's the industry standard for measuring actual network throughput. So here is what most people get wrong. They test against one server and thinks that it's compulsive. You need to test against multiple locations, basically to validate that your uplink isn't capped or oversold. So here we are testing against Iranium in Amsterdam with a 100G network. Here we are getting 9.41 send and 9.41 receive with 0.8 milliseconds of ping. That's nearly full utilization of 10 Gbps. This proves that the hardware and the local network can deliver. So now testing it against Cloudreader in London. Here we are getting 8.4 Gbps send and 7.67 Gbps receive with 6.6 milliseconds of ping. It's still an excellent performance within Europe. Now watch what happens with distance. Testing against LeeSweb in New York. 2.77 Gbps send and 3.31 Gbps receive with a ping of 75 milliseconds. Singapore, 1.39 Gbps send, 1.53 Gbps received. That's 154 milliseconds ping. So this is normal and expected. Here transcontinental connection drops due to latency, routing and TCP window scaling. The further the distance, the harder it is to saturate the 10 Gbps with standard TCP. So here is the key takeaway. Nearby server hitting 9 to 9.5 Gbps sustained prove that your uplink is legitimate. Distance server testing slower doesn't mean your bandwidth is capped. That means physics exist. So always test with multiple endpoints in different region. And if every test is at 2 Gbps regardless of any location, your provider is throttling you. Fourth point, CPU and memory benchmark. CPU performance matters for compute-intensive tasks. Here we are using Geekbench 6 to measure both single and multi-core performance. Here single core performance is 715, its multi-core performance is 6607. So what do these numbers mean? So these are mid-tier enterprises cores, perfectly fine for web servers, databases, virtualization, and most business applications. If you're running standard workloads, this CPU will handle it easily. So there is another important topic we should consider: latency and routing. So latency matters more than bandwidth with certain applications. So our local ping is 0.8 milliseconds to Amsterdam, 6.6 milliseconds to London, 75 milliseconds to New York, and 154 milliseconds to Asia. If you are hosting game servers, trading bots, or blockchain RPC nodes, so this pings directly affects the user's experience. Low latency to your user is more important than more bandwidth. So here are 5 quick tips for accurate testing. First, run every test at least 3 times. Then average the result, because sometimes network performance varies. Second, avoid testing during peak hours. Test at 3 AM and 3 PM to see the both extremes. 3. Disable VPN and proxies during test. They add overheads that skews the results. 4th, compare against known 10 Gbps peers in your region. If every other server in Amsterdam is reaching 9 Gbps but yours hits 3, that's not routing, it's throttling. And 5th, monitor CPU usage during IPERC 3 test, because if your CPU maxes out, so that's your bottleneck, not your network. And subscribe to RedSwitches for more such content.